Hi, in these videos we're going to explore simultaneous equations where one of the equations is quadratic or nonlinear. Now, let's appreciate the idea of how a graph corresponds to an equation. So for example, if we wanted a graph of the equation y equals x squared minus 4x plus 7, then this graph consists of all points xy that satisfy this equation. And similarly, this graph here consists of all points which satisfy the equation y equals x plus 3. And so therefore, where the two graphs cross, where they intersect, these points A and B, because they lie on both graphs, they must satisfy both of the equations. And therefore, we want to solve these equations simultaneously to find values of x and y which satisfy both equations at the same time, simultaneously, as we'd say. Now, in this first video, we're going to keep it relatively simple, and we're just going to have this idea of if you've got a point that lies on both graphs, it must satisfy both equations. Now, we're told that these graphs intersect at A and B, and we want to verify that the graphs intersect at B when x is 4. So when we've got x is 4 here, if I just draw it, x is 4 here, then we need to verify that this point here, B, lies on both the graphs, so it's where the graphs intersect. So all we need to do is substitute that 4 into both of these equations and verify it works. So let's do that. When x is equal to 4, what about this first equation here? Y equals x plus 3. So y is equal to the x value of 4 plus 3, and that is equal to 7. So we know the point B, if it was just on the straight line, would be 4, 7. And what about the other equation? Y equals x squared minus 4x plus 7. So y equals x squared, so 4 squared, and then what is it? Minus 4x is over here. X squared minus 4x plus 7, so minus 4 times 4, minus 4 times x, and then it was plus 7 at the end. And if we do that, that gives you 16 minus 16 plus 7, and that is equal to just 7. And you can see that these two values are the same. So the y value is the same for both of these equations when x is 4. So therefore, these graphs must intersect because the point B, which is 4, 7, lies on both of those graphs. It satisfies both of those equations. So let's just write at the end. Therefore, B lies on both graphs. And we're done.